All right, so to differentiate this equation, we're going to need to use the chain rule. So what we have here is a function inside a function. So we have on the outside the cosine function. On the inside, we have the 9x plus 1 function. So what we're going to do is take the derivative of the cosine function, which is a negative sign function, and then multiply by the derivative of 9x plus 1. So what this will look like is that dy over dx will be, remember 5 is just a coefficient, so we're going to have 5 times to the derivative of the cosine function, and we're going to leave everything on the inside the same. So 5 times the negative sign of 9x plus 1 multiply by the derivative of the inside. So multiply by the derivative of 9x plus 1, which will just be 9. And that will just simplify to negative 45 sine of 9x plus 1. All right, now in 58, we got that y is equal to 1 minus the cosine of 2x plus 2 times the cosine squared of x. So we have a function inside this function, and we have the squared function in here. So let me write this as y is equal to 1 minus the cosine of, and in the second I'm going to put the 2x in a different color. So plus 2 times, and remember when you have the squared power here, what you have being raised to the second power is a cosine function. That's what that, and for trig functions, they denote that, it being raised to the second power by putting the exponent there. So this means essentially the same thing. And in here we have 2x. So we're going to take the derivative piece by piece. The derivative of 1 is just 0. We take the derivative of the cosine function, which is the negative sine function, so it'll be minus negative sine, and we keep the inside the same, so minus negative sine of 2x. And we're going to multiply that by the derivative of 2x, which is just 2. So then we're going to add that to 2 times, and then we're going to take the derivative of the exponent function, so the power function. So we use the power rule, so it'll be 2 times the cosine of x. So all that's the 1 power. And then we multiply this whole thing by the derivative of the cosine of x, which would be negative sine of x. And let's just clean it up a little bit. So dy dx is equal to the sine of 2x, or 2, which is 2 times the sine of 2x, plus minus 4 times the cosine of x times the sine of x. Or I just put the sine of x first, doesn't really matter, I guess. And that's your answer. Let's do 2 more. So 59, we got y is equal to 1/2 x minus 1/4 times the sine of, we have 2x in here. This one's pretty easy actually. So dy dx will be the derivative of 1/2 x, which is just going to be 1/2, because the derivative of x is just 1, so 1/2 times 1 if you want to look at it that way, minus 1/4. The function on the outside is the sine function, so minus 1/4 times the derivative of the sine function, which will be the cosine function, and we keep the inside the same. We multiply this by the derivative of 2x, the inside function, which will be 2. And then we can just clean this up. It'll just be 1/2 minus 1/2 cosine of 2x. All right, and let's look at 60. 60, so it's written like this. Y is equal to the secant, the 7 there, of x over 7 minus the secant 5 power there of x over 5. So again, with trig functions, they like to write the powers in different, notation. So let's rewrite this as 1/7 times the secant of x, all to the 7th power, minus 1/5 times the secant of x, and all that is to the 5th power. See, so what you have is the power functions on the outside, and on the inside here, we have the secant of x and the secant of x. So you have just chain rule within each of these expressions, and you're going to just multiply by, the derivative of secant of x. So dy over dx will be 1/7. So taking the derivative of the power function, so using the power rule will be 7 times, keep the inside the same, times the secant of x to the 6th power. And we're going to multiply that by the derivative of secant of x, which will be secant x times the tangent of x. And let me put those in parentheses so you can see it a little better. And then here we'll have minus 1/5. And we're going to do the power function again, the derivative of the power function, because we have an exponent there. So 5 times, and leave the inside the same, 5 times the secant of x, all to the 4th power, multiplied by the derivative of the secant of x. And that'll be, again, secant of x, tangent of x. If I can fit it there. Off, but let me drag it to the next line. And let me just, now we just clean it up, simplify. So we have dy over dx will be, so we have secant of x to the 6th times secant of x. So that'll be secant of x to the 7th. So your textbook will usually write it like this. Times tangent of x. These 5's cancel. And we have secant, this whole thing is to the 4th power times secant of x. So that'll be minus the secant of x, and that'll be the 5th power times the tangent of x. And there you go.